Hello, family. Greetings to you and welcome to Farm Prefect, where we talk about profitable agribusiness ideas and we also share with our farmers insights that will help them scale up their farming journey. We've been exploring catfish farming, and today we want to see how to calculate the volume of water that your pond can hold or take, because it is the volume of water that the pond can take that determines the ideal number of fishes you can stock it with. And that is very important. You should not just stock your fishes anyhow. No, you need to calculate and make sure that this is the amount of fishes that I can stock them with, catfish I can stock them with. When you follow this procedure, your fishes will have enough space and they will grow well. Right. So let's get into it. Basically, there are um, two shapes of ponds. We have the rectangular, which looks like this. Okay, the rectangular pond, which looks like this. And then we have the cylindrical, or one that looks like a circle, like round, like that. So that one we can represent it like this. Okay. Now, the way to determine the volume here is not the same as the way to determine the volume here. But in this video, what we want to do is to focus on how to determine the volume of water that a rectangular pond can hold, or should be filled with. Okay, so I want to um, show you some basic things so that it will help us in our calculation, right? So I want us to do some alphabet. So this point we'll call it A, then we'll call this point B. Let's call this point from this point C. Then let's call this point here D. This is important. Please watch carefully. From point A to B is the height. Okay, height. Okay, then so is the height, which will represent with H. Then from point B to C is the width, which will represent with a W. Then from point C to D is the length, will represent with L. Right. Now, the formula for calculating volume is volume equal to length times width times height. All right. Now, it is these things that we have represented with the L for length, the W for width, and then the H for height. Then the volume itself with a V. All right. I hope you are following. Yes. Now, there is something else I want you to know. Now, you see, when it comes to the height, let's do this. Let's say that the length here is 50 cm. Okay, the length of our pond is 50 cm. Then let's say the width is 30 cm. Okay, the width is 30 cm, and let's say the height is 10 cm. Okay, now, so there is something I want you to know. In every pond, there is an overflow. If your pond doesn't have an overflow, then you'll be in danger, especially if it is in the open. Now, the overflow point is to serve as a check, so that when the pond is overfilled or getting above the ideal level, then the water can automatically get out of the pond. Yes, that one you don't have to open. No, the overflow is there. It is always patent. So anytime water goes beyond that level, then the water will um, go out of the pond by itself. Yeah. So now you see this height is 10 cm, and if it is 10 cm, the overflow will be situated. Let's say the overflow will be situated around 2 cm, around 2 cm when you are coming from the top. So let's say it is situated around 2 cm. Then it means that in our calculation, we cannot be using from point A to B. No, we can't do that. But rather, we'll use from below the overflow point, or from the overflow point to the bottom. So let's say that from the overflow point to the bottom is 8 cm. Yeah. So if it is 8 cm, then it means that the parameters that we have gotten now, our height for the calculation will be 8 cm. So we have a length of 50 cm, width of 30 cm, and then a height of 8 cm. Now be with me. The formula says that we basically have to multiply the length with the width, and then we get the height. So remember the parameters. Our length is 50 cm, so we'll multiply it with our width, which is 30 cm. Then we multiply it with our height, which is 8 cm. All right, I think we need to clean up, so let me clean up. So so what we need to do now is that so where we were was the volume equal to length times width times height, and then we said that our length is 50 cm, our width was 30 cm, then our height 8 cm. All right, now let's do this. We just have to multiply, do the multiplication. So we have 50 times 30 times 8. That would be giving us 12,000. Now there is something. 12,000. Remember, we have a cm here, a cm here, a cm here. So these three, cm times 3 cm, will be giving us cm cube. All right. So we have 12,000 cm cube. Now, our next approach will be to get this cm cube converted into liters. Yeah, liters. We need to convert this figure to liters. Now, to convert this figure to liters, there are things we need to do. First, we have to convert the cm cube to milliliter, which is we will call mils. Okay, we need to convert it to mils, or we need to convert it to a milliliter. Then from there, we'll convert the milliliter to liters. All right. Okay. So keep this in mind. To get this to the liters, we have to first convert it to milliliter, and then I'll convert that milliliter to liters. Now, there are standard conversion values. So, let me clean here. According to standard conversion, now remember what we are trying to convert is 12,000 cm cube. According to standard conversion, 1 cm cube is equal to 1 mil. That is very simple. Now watch. 1 cm cube is equal to 1 mil. All right. So what it means is that if I have 12,000 cm cube, it will basically be equal to 12,000 mil. Bingo. You get it? No much work. What changes is the numeric value, while the measurement, the standard unit remain. The standard unit changes. Yeah. So 12,000 cm cube will be equal to 12,000 mil. Now remember, our goal is to convert to liters. So now that we have milliliter, we should be asking ourselves, how do we get to the liter? Again, according to standard convection. All right, according to standard convection, you can get these things. You can check it on Google and exercise books. Get me one exercise book. It is also the one that I've written the farm prefect on it. It is also on the back of exercise books. Yeah, the convections, the figures are there. So according to standard convection, 1,000 mil is equal to 1 liter. Yeah, 1,000 mil is equal to 1 liter. Now the question then is, 12,000 mils will be equal to what? That we don't know. So let's say that it will be equal to a y. Now we would have to find this y. Okay, so let's go up again. I hope you are following now. Okay, we have to find this y. So in our quest to find the y, we need to basically cross multiply. All right, so when we do the cross multiplication, this is 1,000 times y, so it will be giving us 1,000 y, which will be equal to 12,000. So it is 12,000 12,000 times 1. Okay, 12,000. All right, now that we have this, how do we find our y? So to basically find the y, we need to divide both sides by this 1,000. Okay, 1,000. This 1,000 will take care of this 1,000. All right, this take care of this. This take care of this. So now we have 120 divided. So when we do that, then we'll be having, can you see from here? We'll be having 1 y will be equal to 120 divided by 10. Okay, so when we divide our 120 divided by 10, we'll be getting 12 basically. 120 divided by 10 should be 12. because again that is simple. 120 divided by 10 will be 12. Now remember, this 12 is liters. Okay, yeah. So what it means then is that this pond, what it means then is that 12,000 cm cube. Okay, 12,000. I think I need to do some cleaning so that we can get so that means that 12,000 cm cube is actually equivalent to 12 liters. So then our pond, which has a length of 50, a width of 30, and a height of 8 cm, will be taking 12 liters of water. Now this 12 liters of water is what we are going to use to determine how many fishes can be in the pond. So it means that when we are able to arrive at the liters of water, then we can now determine the number of fishes that we can stock the pond with. So this is basically the calculation, or this is basically how you can determine the volume of water that you should fill your pond with. You should fill your rectangular pond with. In our next video, we will be looking at how to do the cylindrical pond. Yeah, how to determine the volume of a cylindrical pond. Please remember to subscribe, like, and share, comment, and also talk about this page to your family and friends. Let them join. There are good things coming up here. So in our next video, we'll look at the cylindrical pond. And basically that is it. And thank you for always being here. I want to give you an assignment. So let's say that our pond is we have a pond of length 20, then width is width is 5 cm, and then height of 4 cm. No, let me give you the height of 2 cm, 3 cm, height of 3 cm. So length of 20, width of 5 cm, height of 3 cm. This height is from the fill point below the overflow, from the overflow to the bottom. Kindly determine the volume and leave the answer in the comment section. Determine the volume of water that we can fill the pond with and convert it to the liters. Now if you are able to get it correctly, the first person to submit the correct answer has a giveaway today. Thank you.